Hi, it's Bruce here. We're at the NEMCO lab and we're going through our open standard testing procedure. And this is an RF anechoic chamber. Okay, so when you're testing RF meters, you can't have reflections. If you notice in your home, if you're reading an RF meter, as you move around, the readings will vary drastically. That's because of reflections inside your home. These tiles, and behind these tiles are these cones to absorb all RF radiation. So there are no reflections. So the good thing about that is that when we set a meter in a test point for testing, is that it's not going to matter if it moves a little bit or if it's in a different position, as long as it's in the beam width of the transmitting antenna, you'll get accurate readings. So what we're doing here first is we're doing a calibration run. Okay, so this is a known calibrated antenna, and it's going to be measuring the power at all our test frequencies. And then when we're ready, when we've documented that, we're going to replace this with the meters that we're going to test, and we're going to shoot the same power at the meter and compare what the meter reading says as to what it's supposed to say. And that difference is the correction factor. So, and again, this is a styrofoam stand. This whole turntable is on, can rotate. We can adjust the height of the transmitter antenna over there. We can adjust the polarization of the transmitter antenna. So without being in the chamber, we can set all this stuff up beforehand. Because if I was to be in the chamber during the test, my body would interfere with the results. So the idea is that nothing is interfering with the results. So we're ready to go.
The test setup here at the NEMCO lab, although simple, is quite arduous. Cones on the floor have to be added after setting up the antennas. Depending on the frequency range you were testing, there are two antennas, such as a log purr and a horn antenna. Failed probes measure and receive power where the meter under test will be placed and compared, all of which are calibrated to a known value combined with the gains and losses associated with the chamber setup, from the cables to the free space losses and antenna gains. The signal generators also have known values and can be used from outside the chamber. Different amplifiers are also required depending on the power and the frequency ranges being tested. Multiple meters were tested at the same standard. Some meters are easier to read than others, and some require extra coordination in order to see the screens. All meters were tested to get the best response, based on the antenna location within the device compared to how it performs when in use. For example, we found that facing some devices towards the source actually performed better, likely due to the screens acting as a reflection. A testing standard is needed for many reasons, one of which is to be able to compare meters more easily. Another reason is if we want to get the meters classified as a medical device, they need to be understandable to those at the FDA and Health Canada, as well as all being manufactured to roughly the same specifications. And in order to do so, they need to be able to perform to particular parameters. The long-term goal is hopefully to make a difference in the legislation for the bands of the telecommunication technology industry. These tests need to be done in a chamber, not only because it keeps signals from reflecting, but also keeps outside signals from interfering. All of this will be a very long process, starting with the collection of a lot of data points, testing and retesting to ensure that the test itself is sound. Dialing in the process takes time. When testing, the setup must remain the same between tests. Slight variations of cones, antennas, and meters can have drastic change effects. As Bruce said, we cannot be inside the chamber and interfere with the testing, so being able to run the test from the outside of the chamber is key. Plus, it is dangerous to be inside the chamber at some levels. We use these tests to determine the correction factor, and from that, we can determine the accuracy of the meters. All in all, getting the meters tested is a long, expensive, and difficult process, but the end result is well worth it.